as promised, when we're looking at our IntelliJ IDEA, we'll talk about some of those .class files, .java files. So .java files are the ones we wrote. .class files are the ones that were generated by the compiler. So we're going to be exploring those concepts in this section. So a little bit of review. Remember, source code is the code that we write. That's the human readable version. Again, up to debate, right, for us beginners, because so far the codes kind of seemed a little bit mysterious, but we'll get more and more familiar with the Java rules, and it'll certainly feel more human readable as we go along. So yeah, that source code is translated by a compiler. We're going to talk about how Java code actually has a compiling step and an interpreting step. That's also technically review though. And then remember, compiler is a specialized program that translates source code written in high-level programming languages, in our case Java, into machine code. These are the steps for compiling Java code. So we have source code, compiler code, and then it's output into bytecode, which is those .class files. So what is a compiled language? It's one where the source code is translated into machine code by a compiler before it is executed on the computer. So the steps for compiled languages are you write the source code, it's translated by the compiler, and then it's executed right by the computer. So advantages of compiled languages are that they're more quickly executed. The code is directly translated into machine code, so that's faster performance when you run it because it's already been translated right. You don't have to worry about it once you're running. It's ready to go essentially. Optimization, so compilers can optimize the code during the translation process, improving efficiency. And then no need for interpretation because there's not an interpretation step. The program does not need to be reprocessed by a compiler each time it runs. Once it's been compiled, it's ready to go. Now, interpreted languages. That's one where the source code is executed directly by an interpreter, line by line, without first being compiled into machine code. So let's look at the steps and how they differ. So first, you write the program right in your high-level language, so that's the same as the previous compiled language. Now, this is different. The interpretation step. So interpreter processes the source code line by line and executes the commands directly. So as it's reading, it's also executing. It's kind of doing two things at once. So the interpreter translates and runs the code in real time without needing to generate machine code beforehand. So there's not really that like preliminary step of translating everything at once. It's doing two things at a time. So advantages of interpreted languages, portability, because you don't have to create a separate translated code, like a separate version. The same source code can run on any machine with the appropriate interpreter installed, so you're going to be taking up less space. Flexibility, it's easier to test and debug as you can run the code immediately without needing to compile first. So yeah, there's not like different types of errors, right? Since you're always running the code anyways. So there's not compile errors versus run errors. And then the same code can be executed on different platforms without modification as long as the interpreter is available. So where does that put Java? Well, Java is a little bit of both. So when Java compiles to bytecode, so that's our source code turning into bytecode, it's interpreted by the Java virtual machine. This is the part that makes it machine agnostic or run anywhere, the write once, run anywhere, or WARA. That Java virtual machine, that extra layer means that it doesn't matter which computer it's running on. This is the kind of the layer that abstracts it for your actual device, actual computer, your actual hardware. So it's a combination of both compiled and interpreted. So Java is a hybrid language. Hybrid languages first compile the source code into an intermediate format, such as bytecode. That's what the compiler is doing, turning your code into bytecode. And then that's interpreted by the JVM. So it combines benefits of both compiled and interpreted languages. So you're going to get the portability, you're going to get the performance optimization, and you're going to get the cross-platform support. So a little bit of review. We kind of touched on this briefly last time, but now we have a little bit more information. We write these files, Java compiler translates them, generates these class files. That's why we have the .java files and then the .class files in that out folder. And then the JVM actually interprets that code before handing it over to your operating system. We'll actually read it down in the machine code version. So a little bit more on compiled versus interpreted languages. Definitely check out this video on the difference between the two. So again, kind of wrapping it all up, right? Coming full circle. Those .java files we saw in our IDE, main.java, these are the ones we write. That's source code. So the .java files are source code. They're human readable. Not really yet, right? Since we're still learning. The code is stored in plain text format, so it's just regular text. It contains all our classes, methods, statements, etc. Before it's executed, it's got to be compiled. Once it's compiled, it's going to generate a class file, which again, if we go to our out folder here, we see a corresponding main.class file. Again, this is not what it actually looks like. My IDE is kind of doing some tricks so that you can read it. But if I go to the original file here, open it on a different program, or I think I could do it directly for here. What am I doing? So you can do right click, and then you can go, it's one of these, open in Explorer, there it is. And then I can just open with, for example, Notepad. And this is, you can see this is the bytecode, which, I can't even read it on my Notepad because some of this is not even valid text. So yeah, that's kind of the nonsense interpreted code that's going to be handed over to the JVM. So yeah, the .java code that you write is translated into bytecode. So that's why we have .class files generated every time we run our code, every time we compile it, so that the JVM can execute that code. It's created automatically when you compile a .java file, and that means it can be run on any machine because of the JVM. The JVM is kind of that layer in between the bytecode and your actual machine. So JVM is able to send it to the proper machine code for your computer. And that's it for this lesson on coding in Java. Next up is going to be our lab.